Hey guys, welcome back to the Career Guide Academy. Let's start with the today's fourth lecture of electrostatic, in which we are going to learn about the electric field. Okay, so before starting to the electric field, I would like to explain the things what we have learned in Newton's laws of motion, right? So in Newton's laws of motion, we have categorized the forces into two categories. First one is the contact forces and second one is the field forces. So contact forces means if I am applying the force in between these two hands, so there is a contact between these two hands and they are going to apply the force. So this force we can be able to see also and we can be able to feel also, right? So we can able to experience and feel, both things will happen. But if I drop this chalk, right, it is going to go down because of the Earth's gravitational field that we have learned in the gravitational chapter, right? So basically, even though there is no contact between this chalk and the earth is trying to pull it down. Another example, if we keep two magnets, right, near to each other, what will happen? One magnet will try to attract or repel the another magnet. So there is no contact between them, still it will apply the force. So such a forces where there is no direct contact between the two bodies or two substances, but still there will be a force. Such a forces are called as field force, and electric force is one of them, right? So basically, if we consider any charge, capital Q, right? So this Q charge will be having ability to attract or repel the charges which are going to come in the influence of this capital Q charge. Means there will be a certain region. In this region, if that charge is coming, this capital Q charge is going to apply a force on that small q charge, right? So basically, if we consider that small q charge over here, it is within a region, means this capital Q charge will apply a force on it, right? So basically, this region within which this capital Q charge is going to apply a force is called as electric field, right? So this is one of the definition of electric field. Now let's talk about the another term, electric field. Means electric field can be defined in another way also, right? So basically, if this Q charge is there and this small q charge is there, there will be a force of attraction or repulsion between them, and that will be equals to Q divided by R square, where R is the distance between these two charges, right? So basically, whether this Q charge is present or absent here, it doesn't matter. Whether this small q charge is present or absent, it doesn't matter for this charge. It will have always ability in this region to attract or repel the another charges, right? So basically what I am saying, whether this small q charge is present or absent over here, it is not going to change the ability of this q charge to apply the force at this point, right? So let's consider point P. Means this capital Q charge is having ability to force any another charge whenever it is coming to this point P, right? That ability of the charge to attract or repel another charges, that is called as electric field, right? So if I want to define it mathematically, we can say electric field is nothing but the force acting on any unit charge. This charge we are going to call as unit or test charge, right? Or test charge. So basically, the electric field is defined as the force acting on a unit charge, or you can say force acting on a test charge. So force acting on a test charge, we know that it's Q divided by R square. If I divide it by small q, means the magnitude of this test charge, so we are going to get the quantity, that is electric field, that will be equals to kq by R square, and this value is independent on the small q charge. Means whether this charge is present or absent here, it doesn't matter. This electric field at a particular point will be always kq by R square for this particular charge, right? So electric field we have defined by magnitude, that will be equals to kq by R square. Then what about its direction? Why it is vector quantity? So basically, if we consider electric field is the ratio of force where force is the vector quantity and charge which is the scalar quantity. So vector divided by scalar will be always vector. So we can say electric field is the vector quantity. So we have to define the direction of electric field also. Yeah, we have to define its direction also. So basically it is very easy to define its direction. If we consider the electric field is equals to F bar by Q. It means whatever direction F bar is having, same direction electric field will have. So it is very easy. In Coulomb's law in vector form, we already learn how to show the direction. So basically if we consider this as 1, this as 2, then we can say the direction towards 2 from 1, that will be equals to position of 2 with respect to 1, and we have to show the direction in unit vector. So electric field will be always along the direction, right, which is going away from the positive charge, So basically whenever we are talking about the electric field and we want to find out its direction or its magnitude, we are going to consider the test charge. And keep in mind, this test charge we will always consider of unit magnitude, and it will be always a positive charge. So if we consider the electric field now, that electric field will be equals to kq by r square, and direction will be equals to going away from the positive charges, right? So basically if you want to talk about the electric field direction, you have to remember it will be always going away from the positive charges, right? Now if we talk about the force, right, let us consider we don't know this charge, right? In some region there is a electric field, right? So let's consider there is a electric field. I am going to show with the arrow, and I am going to say its magnitude is E bar, right? So if there is a electric field E bar, right? So at this position, if I keep certain charge, let us say small q, so this electric field is going to apply the force on this charge, right? So basically if we are not seeing this part, we are just seeing this right side part, there will be a electric field that will be equals to kq by r square, right? And we are saying that in this electric field we have kept this small charge. So in this electric field, if I keep this small q charge at this particular place, then we can say the force acting on this charge, that will be equals to E bar into Q. So basically the force that is going to act will be always in the direction of electric field. So basically if we talk about this electric field now, this electric field will be always exist. So if we consider any charge, there won't be force exist first, there will be always field exist, right? So field will exist first and then force will come. So first of all we have learned the forces and then we have derived the electric field. So basically always we have to remember electric field will exist first, and due to electric field there will be a force on the charges. So we are going to stop here today. In next lecture we will learn about the electric field lines and how electric field lines can be drawn for the point charge or any other charges, right? So we'll stop here today. We'll continue in next lecture. Thank you. Thanks for watching.